In this video, we're going to use properties of logarithms to help us solve the equations, and then use the one-to-one property, and then also check graphically our solution. So the property of logarithm, if you have here, we're looking at this plus. We're going to use this property, log of P times Q. So if you have a log of a product, that can be expanded to be a log of that turned into a sum of logs of each of the factors. So we're going to use that here. Now, so this is natural log of x plus 2 times 3x minus 2. And on the right hand side, it's just, we're also going to use this property, log of p to the x is equal to x log p. We can bring this x out in front. And so we're going backwards. We're going to put this 2 back. This 2 is a exponent. Bring it back in. So this can be rewritten as natural log of 2x squared. We're squaring that whole argument. So now we have natural log both sides. We can use one-to-one. This is x, and let's just write what we've got. X plus 2 is 3x plus 2 minus 2 minus 2 is equal to 4x squared. Let's use the distributive property here. We have 3x squared. Let's see, minus 2x plus 6x minus 4 equals 4x squared. Now this is a quadratic equation. We need to set it equal to 0 and see if we can factor. So we'll subtract 4x squared from both sides. That's 0 on the right. And on the left we have negative x squared plus 4x, combining those x terms, minus 4. Let's multiply through by negative 1. Negative 1 times 0 will be 0, so that's not going to change anything. And let's change color here. So at this point we've got x squared minus 4x, change all the signs, plus 4 equals 0. Now, factoring looks promising here. We'll bring down the x, We're looking for factors of 4 that add up to be negative 4. There's not many choices. Negative 2 and negative 2 equals 0, or x minus 2 squared is equal to 0. And the solution to this is x equals 2. Nice even numbers, sounds promising. So let's go to a graphing application, the Desmos grapher. Nice grapher. And put in our expression. It was natural log x plus 2 plus natural log, I'm putting in the original, 3x plus minus 2. And that's that. Let's get a good look at this. So it appears to have a asymptote. That asymptote is, I don't know. Anyway, about a half. Nevertheless, on the right-hand side, it's 2 natural log of 2x. Now, there's our graph. Looks like that's our intersection, and it intersected at x equals 2. Verifies what we want. One intersection, and you can kind of see the I guess it's a green line just touching the blue graph, but it's not intersecting in 2 places at all. It takes off now and rises a little bit faster, so it's always staying above but just touching right here. All right, so let's verifies our answer. Let's take a look at our other one. Now here it's a minus, so the other property when we have a minus is the log of p over q is equal to log p. If we expand it, it's minus log q. That's property. Now this means that I can rewrite this expression as a rational expression. So on the left I have a natural log of 7x plus 3 over x plus 1 equals natural log 2x. I have single log expressions on both sides. I can apply the one-to-one property and just solve, leave out the logs and just solve with the arguments. So 7x plus 3 over x plus 1 has to equal 2x. Let's treat this as a proportion and do cross products. So this product is equal to this product as I rewrite this equation or figure it out. So let's just say on the left we have 7x plus 3, and on the right it's 2x times x plus 1, or 7x plus 3 is equal to 2x squared plus 2x. It's a quadratic equation, so let's set it equal to 0, and let's subtract 7x from both sides and subtract 3 from both sides. Subtract 7x, and what we get on the left is 0, and on the right is 2x squared minus 5x minus 3. We need to see if we can factor this. This is negative 6 is our product, and our sum that we're looking for is negative 5. Negative 6 and 1 will do the trick. So in our factoring process, we'll do 2x, bring 2x into both these factors. 2x minus 6, 2x plus 1, and that's equal to, well, it's not equal yet. This doesn't really, we're not done yet. We have to divide out. So we have x minus 3 and 2x plus 1 equals 0. Now, so the solution kind of ran out of room. The solution is x equals positive 3 or negative 1/2. Now, we want to look at that graph and see if this verifies, if we can verify that. So we'll come to the graph, and on the right-hand side, it was just natural log of 2x. So that changed that a little bit. And on the upper part, it was 7x plus 3 minus x plus 1 plus 1. Now, so there's one of our points of intersection at 3, so that's good. But we have this these two graphs are not going to meet again. You can see this, they're both, this green one is continuing to rise at a faster rate than the blue one. The blue one is shifted further left, and it appears we're reaching asymptotic behavior. They aren't going to intersect at any other point than 3. And now, so there's really only one solution. Why is that? Well, this x equals 1/2. This right here will cause a problem when we plug in negative 1/2 right here. So 2 times negative 1/2 is equal to negative 1, and that means we would be taking the natural log of a negative number. We can't do that. That's an extraneous solution. So this is extraneous. Interesting.